Good afternoon, everyone. Thank you for joining us today for the webinar on designing appropriate rate structures for water and wastewater utilities. My name is Shadi Eskaf, and I'm a Senior Project Director with the Environmental Finance Center at the University of North Carolina at Chapel Hill. A little bit about me. I'm Shadi Eskaf, again, Senior Project Director. I work for the Environmental Finance Center, which is in North Carolina, but we really serve Region 4, which is the southeast of the United States, as well as the rest of the country. We do some national projects as well, but we are a center that's focused on helping local governments and other environmental service providers figure out how to provide environmental services in fair, effective, and financially sustainable ways. So that's our mission statement, and we do that through a lot of applied research and teaching and outreach like this webinar, and also program design and evaluation, which also means that we do a lot of direct advising. So we have received funds from ADEM as well as other organizations to be able to answer your questions on any issue that's related to environmental finance. And for this particular webinar, and what I focus on is water finance. So water and wastewater rates, capital planning, rate structures and rate setting, anything to do with the financial aspects of managing water and wastewater utilities, I'm happy to provide assistance on. We did a webinar about 4 or 5 days ago, on Thursday of last week, and that webinar was focused on reviewing the state of rates for the state of Alabama, how nearly 450 utilities across Alabama were charging, or how much they were charging customers as of 2016. We had done the survey with the Alabama Department of Environmental Management, ADEM. So ADEM has funded a rate survey as well as these 2 webinars, and we appreciate ADEM's sponsorship of this so that we could provide assistance to local governments and utilities in the state of Alabama. We did, as I mentioned in the last webinar, that we completed a rate survey of about 450 utilities. We calculated a lot of what utilities are charging, and we created a rates dashboard that's an interactive tool available for Alabama utilities to be able to compare and benchmark rates and rate setting. In that webinar, I unfortunately failed to mention that if your rates are not in there, please feel free to send me an email, and I can provide some instructions sometime this week, hopefully, on how to add your rates and how to use the rates dashboard as well. ADEM is a great organization to work with, and just to let you know, if you haven't used ADEM recently, they do have low interest loans and can provide some assistance funding capital projects using low interest loans and basically cheap rates. So that would help you with capital planning and funding your system as well. So the outline for today's webinar will be presenting on the basics of different rate structure design components. And I'll spend a little bit of time explaining the difference between rates and rate structures and focusing on the rate structures parts. I'll be presenting on the basics of rate structure design components and then discussing how and when it's appropriate to favor some elements over others based on the utility's objectives. And I'll also be introducing tools and resources to help you with rate setting along the way. Before we get started, I want to ask a poll just so I have an idea of who's in the room. So please respond, let me know, how much experience and knowledge you currently have about various rate structure designs, not just rates, but the different types of rate structures, base charges, increasing blocks, uniform rates, and so on. I just want to get a sense of how much of the background, how much of the details we should go over, or if we need to just skim through those and get into the meat of the discussion. So I'll give you a few more seconds. Okay, thank you. So as you can see, almost everybody here, most people have, 2/3, have 5 or more years of experience with rates and rate setting. So you're already versed with the terminology and you already know about rate structures. So maybe what I'll be doing is spending less time on the very, very basic So I'll be skimming through some of the descriptions of what uniform rates are, or increasing block rates are. But for those of you who are new to this, please slow me down if you need to. Please submit a question, ask me to clarify something if I haven't explained it in enough detail. So submit a question, and I'll be happy to go back and explain a little bit more detail. But I'll try to go through the basics a little bit more quickly and spend a little bit more time about choosing between the different rate structure designs and when is it appropriate to do one thing instead of the other. If you already have some questions in mind, please feel free to submit them now. You don't have to wait till the very end to ask your questions. Thank you. So quick terminology, just so that we're all on the same page. Let's look at this example of a rate structure. This is a made-up example, but it's just illustrative right now. So this utility is charging for water $32 a month. That includes the first 2,000 gallons of consumption. And then they add $2 per 1,000 gallons for any use between 2,000 gallons and 5,000 gallons. $5 per 1,000 between 5 and 20,000 gallons of use, and $6 per 1,000 gallons for all use above 20,000 gallons. So this, you're probably all familiar, this is an increasing block rate structure because the volumetric rates are always increasing. They go from $2 per 1,000 to $5 per 1,000 to $6 per 1,000 based on the volume of water that you're using. The distinction between rates and rate structures, the rates are everything you see in blue. It's the dollars and cents, $32, $2 per 1,000 gallons, $5 per 1,000. Those are the rates. We're not going to be talking very much about setting rates. We're not going to be talking about how do you determine what those numbers are. I'll mention at the very end a tool and some resources that are available to help you figure out these numbers, but the focus of today's webinar is going to be on the rate structure design itself. So how many different levels, how many different blocks, do you use a block rate structure or do you use uniform rates? Do you have a base charge? Do you include a consumption allowance? Just all those, the design aspects of the rate structure itself, that is what we'll be focusing on in today's webinar. And we'll save the discussion about rates part for another day. There are different terminologies, different words, different terms that utilities are using for the same thing. So in this case, it's $32 per month. We call a base charge. Some utilities might call it a minimum charge or a fixed charge or an administrative charge. Whatever you call it, it's the same thing. It's whatever the dollar per month or dollar per billing period is, regardless of the consumption of use. So I'm going to be calling that base charge. Be calling the amount that's included in that base charge a consumption allowance. The volumetric rates are everything that you're charging per 1,000 gallons or per 100 cubic feet above the consumption allowance. So those are the rates themselves, the volumetric rates. And then if you have block rates, it's, as you're familiar, where you end and start new blocks, the prices then, or the rates then change. Second question to ask you in the audience. Now that we're talking about rate structures, I want to know before we even get started, when was the last time that your utility seriously considered changing the rate structure design? Not the rates. You might have raised your rates the past 10 years. Doesn't matter. I'm asking you about the rate structure design itself. So when have you considered switching from a uniform rate or decreasing block rate to something else, or perhaps changing the consumption allowances, including a new base charge, or changing the balance between your base charges and the volume, intentionally changing the balance between your base charge and your volumetric rates. So you're doing something to the design of your rate structure itself. When was the last time that your utility considered doing something, changing it, even if you have not actually changed it? And my experience in talking to a lot of utilities is that it's more common for utilities to review the rates and to update the rates, to change the rates, than it is to look at the rate structure design itself. A lot of utilities just take the rate structure design from last year or from several years ago and not change them, but just look at changing the rates number to make sure the revenues that they're producing are going to be sufficient next year. All right, I'm going to close that in 3 seconds. All right, thank you. So it looks like for most of you, you've actually reviewed the rate structure design recently, within the past 2 years or within 5 years. More than half of you looked at that. Some of you have not looked at changing a rate structure design for more than 10 years, which is, like I said, not uncommon because a lot of utilities just stick to the rate structure, they're happy with it, or they don't even think about it, and they just look to change the rates and make sure that the revenues are going to be sufficient. And for some others, don't know it's before your time or not applicable. So thank you for that answer. It looks like it's actually much more common amongst this group of webinar attendees to look at the rate structure design and think about changing it than I've seen in other areas. One key message I want to make sure is very clear to everybody is that we always say there's no one rate structure that works perfectly for all utilities. No one size fits all. We're not going to talk about one rate structure that's going to be a magic bullet or a silver bullet that will solve every utility's problems. Every utility will and probably needs to have a separate and a unique rate structure that fits its customer base and its needs. That's going to be very different from the neighboring utilities or from any other utility in the state. So keep that in mind. Every rate structure, every utility has a need for a unique rate structure. I'm going to be mentioning a lot of things that we have already written in a resource guide that's called Designing Rate Structures That Support Your Objectives. It was originally written and funded by the state of North Carolina, and it was written for North Carolina utilities. There's maybe a few things in there that are North Carolina specific, especially about laws in North Carolina, but vast majority of that resource is really applicable to any water utility across the country. So I'll be showing a lot of screenshots of some of the elements that were in there, and we'll be describing some of the rate structure designs from there, as well as some of the examples. The PowerPoint slides will be posted, or actually already posted on our website on the same page that you would have downloaded or you would have registered for this webinar. I will be sending out a link to these PowerPoint slides. You can also see the PowerPoint slides in the handouts section in the control panel, as well as a copy of this resource guide. So you can either go on the PowerPoint and find this link and download it yourself, or you can just download it from the handout section of the control panel right now. So going over or reviewing rates every year, there are a lot of questions that utilities and staff have to consider. The most common, of course, is will the rate structure provide enough revenues for next year to achieve cost recovery? And there are questions about what cost recovery means or full cost pricing, what are you going to be charging for exactly and who's going to be paying for that. But there are a lot of other questions that you need to be considering. Are we following applicable laws? Are we allocating the cost to the right customers, so those who are using more are spending or paying their fair share? Will our customers understand the rates? So how simple is it? Will our customers be able to pay for these rates? Affordability issues? Do the rates send the right signals to customers based on our objectives, which is going to be the focus of today's talk? Will the revenues be resilient to changing water demand? So a lot of things that you have to balance as you're setting rates. A lot of these things really get addressed better from the rate structure design as opposed to the rates section. So we always advocate that you do spend every 2 to 3 years or so looking at the rate structure design, seeing if the design itself is still valid for what the utility's objectives are and what the customer base looks like, and reviewing that every 2 or 3 years. Doesn't mean that you need to change it, but at least review them and make sure that you address all of these questions through the rate structure design first before you start calculating what the rates need to be. And we're showing this here in a schematic. The process, at least the general, very simplistic way of looking at rate setting is that throughout time you're constantly learning more and more information about rates and rate structures. So attending these webinars or talking to colleagues or just reading about rates and rate structures or going to board meetings. So you're learning a lot about the background on rates and rate structures. To do really appropriate rate setting and rate structure design, you need to understand the characteristics of your utility, your community, and your utility's priorities. We think that you need to be starting with this. It's a little bit sort of like strategic planning. Start with these strategic goals before you start designing your rate structure or before you adjust your rate structure, so that you make sure that you're addressing all of your high-level goals first and that you know who you're serving and make sure that you're structuring your rates to best achieve your objectives based on your utility and your customer characteristics. And I'll show some examples of that. Once you understand what the characteristics of utility are and your customers, then you design your rate structure itself, the design of the rate structure. And then once that's approved and you think they have a good rate structure design, then you start calculating what the rates need to be. And once you've done that, you need to do a little bit of a circular or iterative approach where you review what your proposed rate structure is going to be in the end with all the rates, see if it meets all the objectives they originally set to meet. Is it going to generate all the revenues you need? Is it going to support all the objectives? And if it's not, then go back and adjust the rate structure design and the rates. So we're separating out the rate structure design and rates again. So let's dive into it. Understanding your utility and served community. What are some of those questions that you need to be asking? How are your customer demands changing? Are you seeing that total demand is decreasing or increasing? Are you seeing a huge growth in your community? We're seeing a lot of utilities, actually most utilities around the country, have been witnessing a decreasing average demand, especially on the residential side. And that's been going on for a while, but especially after droughts or after water shortage periods where utilities have encouraged customers to conserve, a lot of utilities have found that the customers don't go back to their pre-drought levels of consumption. They've learned to, or they've changed something, changed their habits or changed their appliances or so on, and they've reduced their consumption. These kind of long-term trend analyses would save your utility a lot of time and hassle when you're setting rates, because you don't want to be projecting high growth or linear growth in your consumption and then set your rates based on that and find out that your customers are using less water than you're projecting and end up with less revenue and having to increase your rates more significantly then. So knowing your customer demands over time, do you expect to meet those demands? Do you have enough supply? Or if you don't have enough supply, then maybe you need to be trying to encourage conservation and water efficiency, and you can do that through the rate structure, and I'll show some examples. What's the makeup of your served community? Do you have a lot of large families? What's the ability to pay? What's the income level for the community or the socioeconomic conditions? Is it a seasonal community? You have a lot of people coming in, going out during different times of the season. Is there growth or decline in the number of customers and the use? How much of your revenue is coming from your non-residential sector? If your largest two customers, a poultry plant, for example, or a large industry, leave town, how much of a hit would that be to your revenues? And how much, how would you be able to weather that with your current customer base? So these are kind of questions you need to be aware of as you set your rate structure design. As well as some of the cost side and the dollars and cents side. So in the past few years, have you, how much of your revenues and how much of your costs have been fixed or variable? And the more fixed your revenues, the more stable they are, but they could also be discouraging of conservation. Most of the utilities will find that their costs are very fixed. Your debt service, your capital costs, your short-term salaries, or labor, materials, most of those things are very short-term fixed. They don't depend on how much water you sell, only power and chemicals. And if you're a purchase system, purchasing water, those are the truly short-term variable costs. And for most systems, it's actually very low. Have your operating expenses changed over time? Is it going up? Is it going down? How quickly is it increasing? And then do you know any capital expenses or debt service payments that will be coming up going forward? Do you anticipate any potential changes? So know all these things in advance before you start setting your rates. The next step is to think strategically about your utility. You cannot, I would say that it's very difficult, probably impossible, to meet all sorts of objectives that a utility would typically want to see with one rate structure. I don't think that ever really happens. I think there's always going to be trade-offs. So for example, we're showing 4 different objectives here. Full cost recovery. You know, how many utilities would like to have enough revenues coming in to pay for all their costs, including capital? I hope the answer is everybody. So full cost recovery is usually a high priority, high objective. Maintaining affordability is one that we see a lot. as well. Utilities would say that we keep raising rates, but our customers are starting to complain, or it's actually starting to hit a lot of people, and it's hard for them to keep paying, at the low end consumption, hard to pay for those bills. So affordability is becoming an issue for some utilities. Some utilities with supply issues or just long-term strategic planning, they want to encourage conservation, and some utilities want to use their services to encourage businesses to move into town. So these are 4 objectives out of many, many different types of objectives that you might have. And you can see some trade-offs here. If you want to encourage full cost recovery, and if you prioritize that, affordability might become a little bit of an issue for some utilities. Or if you're trying to encourage conservation and you set really high rates for high consumption, well, that might hurt some of the industry, and that might make your utility or your town less attractive for water-using industries to move into town. So there's some trade-offs in using these. So we always recommend the utility to sit down and to think about these objectives and to prioritize them. Actually force you to rank them from 1, 2, 3, 4 onwards, what your main priorities are. And that really should be a strategic decision-making process that your board or your council should be going through and help direct, because it's a little bit more broad-based and looks at the objectives of the community as a whole. But for now, let's use the staff or whoever's on the call right now to do this through a poll. So if you had to pick one of these 4 and then the 5th other objective, which would you rank as your utility's most important objective in influencing your rate structure? Is it to encourage economic development? Is it to recover costs? Is it to maintain affordability? Is it to promote water conservation and efficiency? Or do you have some other objective that you want to achieve with your rate structure? What's your single most important objective? All right, I'm going to close it in 3, 2, 1. Okay. So 90% of you said recovering costs is the most important objective. 10% said encouraging economic development. All of these objectives are valid. All these objectives, depends on the utility. There are a lot of different reasons why some of these objectives are more important than others. Recovering costs, typically we see that really, really high on utilities lists. Encouraging economic development is growing for some communities, especially some small towns that might have lost industry and need to recover, because if you encourage economic development, then you might be able to do some of the recovering costs part as well. So there's some objectives, some different reasons for having these different objectives. So thank you for doing that. I'm going to ask you now, what's your second most important objective? So if you already said recover costs is your most important, don't pick that. Pick something else. And if you've picked encourage economic development as your most important, what's your second most important objective? So now we're starting the process of prioritizing 1, 2, 3, and 4. I'll give you a few more seconds. All right, I'm going to close the poll in 3, 2, 1. All right. So now we're seeing a bit more of a spread, because most utilities said recover costs, and it looks like the person or whoever, I'm guessing the 10% that said economic development is now picked recover costs as second, but maintaining affordability, economic development are ahead of water conservation for this group in particular. But again, different utilities, you can see the spread here. Different utilities have different objectives. So going back to what you said earlier, that no one rate structure is going to help all utilities, you can see that here just by looking at these objectives. So the purpose of doing, thank you for responding, the purpose of doing this, forcing you to go through this process of prioritizing and ranking them, is because when you set a rate structure design and you are faced with trade-offs, do I raise my base charge? Do I include more consumption allowance? I think the best way to answer that is to always go back to what your objectives are and always try to meet your first and second objectives first before you think about some of the other objectives that you have. So, always ask yourself, by changing the rate structure design the way that I'm proposing to do it, is it helping or hurting my highest priorities? And that way, you're not having to balance so many different objectives and finding it impossible to do everything with one rate structure design. So here are some of the elements of rate structure designs. I'm going to go through these quickly because you're all familiar, or most of you are familiar with them. First, it's deciding different types of customer classes and charging different rates and different rate structures for different types of customers. And I'll go through each of these bullet points separately. It's the billing period, how frequently do you charge customers, the base charge, the consumption allowance that is included with the base charge, volumetric rates, and how you structure those volumetric rates, whether it's uniform rates or increasing block or something else. If you have a block rate structure, it's decisions, you have to make some decisions about the number of blocks, the block sizes, and the rate differentials. And I think a lot of the community characteristics will help influence the answers to those questions. And then there's optional having automatic adjustments, and that means, for some utilities, they're finding things like having a drought surcharge or whatever you want to call it, but some process by which rates automatically change, rate structure automatically changes, or the rates automatically change temporarily based on external forces. That helps with some of the objectives, like recovering costs and encouraging conservation. So I'll talk a little bit about that, but I might not talk a lot. If you are interested in looking at drought surcharges or other kinds of automatic adjustments to your rate structure design, feel free to send me an email, and I'm happy to schedule a time to talk. Customer classes and different types of rate structures that you can charge. Most common for very small systems is to have one rate structure that applies for everybody, and that just treats all customers as equal. The next level would be to have a different rate structure for residential customers and something else, either non-residential or commercial, and have a separate one for industrial, and have a separate one for residential irrigation. So you can have different types of rate structures and different rates for different customer classes. And each of these, the rate structures target each customer class, but within all the customers within that customer class are treated equally. One rate structure, but have different base charges based on the meter size. That seems to be very common as well, which means I'll charge everybody the same volumetric rates. I'll charge 5/8" meters $35 a month. I'll charge 1" meters $50 a month. I'll charge 2" meters $100 a month for a base charge. And the volumetric just applies to all. So by doing that, you're really targeting the non-residential and the multifamily housing customers because of their larger meter size and the greater peaking demands on your system. One rate structure for all, but the blocks implicitly target non-residential use. I'll explain that in another example, another slide. You can also negotiate. In some cases, you have to be careful because sometimes these things might not be legal. But in some cases, you might be able to negotiate rates with high-use customers. That's typically done with bulk customers, with wholesale. If you're selling water to another town or another utility, you can kind of consider bulk customers as something along the lines of this type of classification. And then some utilities have different rates for outside municipal limits. In Alabama, we looked at these statistics last week. I think in Alabama it was somewhere about 15% of rate structures have a different rate for outside customers. For municipalities, only about a quarter of the municipal systems have outside city rates that are different than the inside city rates. Some quick statistics for Alabama. Some of these we talked about in the last session. 43% of utilities of the rate structures and 52% of wastewater rate structures have unique rates for commercial or non-residential customers. So they have a residential customer class and a non-residential class, and there's a section, there's some of those utilities that also have an additional industrial customer class. So it's a common process for the state of Alabama to have these different customer classes. And only about 3% of the rate structures have unique rates for residential irrigation. In other states, we see that number to be a little bit higher. And I mentioned only 15% have unique rates for outside customers. The second thing to consider, second element of rate structure design is the billing period. You can go anywhere from monthly billing to bi-monthly to quarterly. With AMI meters, I mean, you could do more. You could do weekly billing if you really wanted to. I mean, you have the option to increase the frequency. The whole point of considering the billing period as an element of rate structure design is to consider the frequency of charging customers. And there's two sides of that equation. One is the more frequent you bill, the more frequent you have to go read the meters, the more frequent you have to mail the bills, the more frequently you have to collect the bills and process them, so that it increases the cost for the utility. But at the other side of it, the less frequently you do that, and because of cost savings, some utilities might have a plan to charge less frequently. It doesn't provide the customers with a lot of direct incentives to manage their demand. So I guess what I'm trying to say is the monthly billing period is more beneficial for the customer, because it means they get, even though it's more frequent bills, they get smaller bills that they have to pay for. So it's easier for the customer to budget and to pay those bills if it's more frequent and smaller in amount. They're also more sensitive to rate changes and to leaks. So if you don't bill except every three months, and I'm a customer and I just paid my bill, and then next week my toilet starts leaking, I won't find out until 3 months from now, and I will get an astronomical bill at that point to pay for 3 months worth of leaks. I know that utilities have leak adjustment policies, but that's also a hassle for the utility and a cost to the utility to have to deal with that, because that's just water that you've treated that you're not going to be generating in revenue for if you provide that leak adjustment. So there are some of these trade-offs between monthly and other types of frequencies. We always recommend looking at monthly billing periods if the utility can afford it, because of the benefits to the customer and to the utility. You get more revenue stability that way, and the cash flow is easier for the utility because you're getting money every single month instead of every few months. For the state of Alabama, nearly every utility, every water rate structure was on monthly billing. I think we found one or maybe two utilities that were charging something different than that. Next element is looking at the base charge, and the question there is just how much to put in the base charge. Do you charge a low base charge, $5 a month, or do you charge a high base charge, $50 a month, or somewhere in between? The higher the base charge, the higher the revenue stability for the utility, because this base charge, this is what's providing your fixed revenue. It doesn't matter how much water the customers use. You can count on this money, for the most part. You can count on this money every single month, and that's what provides your revenue stability. So the higher the base charge, the better it is for the utility. Of course, the higher the base charge, the less affordable the bill becomes for the customer. So there's the other side of the equation. Also, if you raise the base charge, if you switch the balance and increase your base charge and lower your volumetric rates, so you're basically shifting the revenue generation towards your fixed revenues instead of your variable revenues, because you want to generate more revenue stability for the utility. The more you do that, the less incentive the customer gets to conserve and to be efficient with their water use, because they're paying more on their fixed side, and it doesn't really matter how much water they're using, and they're going to be paying less on the volumetric side. Yes, the bill will go up as consumption goes up, but they're not going to be paying quite as much if you're shifting all those costs, all those charges towards the fixed side. So a utility is trying to encourage conservation might find that the price incentive that they set by having a low base charge of a high volumetric rate might outweigh the revenue stability side of the objectives for the utility. For a lot of small utilities, you have a lot of fixed costs, and those are very, very high fixed costs unless you're a purchase system. And you have very few customers to pay for those fixed costs. So having a higher base charge for the small customer base is probably a good starting point to consider when you're setting your rates. There are different ways to charge base charges. You can just charge a flat charge, $35 a month for everybody in that customer class, or you could charge by meter size, and we already talked about that, where you have higher charges for larger meters. If you have questions about using different meter sizes and charging different meters, different rates for different meter sizes, please submit a question. I can answer that. How base charges are priced in Alabama as of 2016. You can see the bar chart here, but I'll talk through the main points. It seems that water-based charges are higher, typically higher than the wastewater-based charges. Actually, we found overall in Alabama, water rates seem to be higher than wastewater rates, which is, compared to a lot of other states, including North Carolina and Georgia, so southeastern states, that's actually kind of unusual. Most states will find that the wastewater rates are significantly higher than the water rates. Alabama is a little bit unique in that sense, where the water rates are higher. The median base charge, so half the utilities in our sample of 450 utilities, half the utilities were charging $18.38 per month or higher. And on the wastewater side, half the utilities were charging $15 or higher. You can see the distribution here. Some utilities were charging more than $35 a month for each service. With the base charge, you have the consumption allowance. You can either include nothing, and the base charge is just for 0 gallons, and your volumetric rate starts from the first gallon. For a lot of utilities, you have a consumption allowance. So the $35 a month includes the first 2,000 gallons, let's say. So any consumption within the consumption allowance does not get charged anything on the volumetric side. The higher that consumption allowance, it might seem that it will provide the utility an opportunity to raise the base charge some more, because you're basically saying that we're providing you with 3,000 gallons of water, so our base charge needs to be high to accommodate all that. That's fine. On the low side, if you don't include any consumption allowance, then what your rate structure is doing is setting volumetric rates for the first gallon, so it's more, it incentivizes water conservation more than a rate structure that includes a consumption allowance. And for some customers, we've heard, especially low-using customers, some customers have complained saying that, why is my utility charging me $50 a month for 2,000 gallons or for 3,000 gallons, and all I'm using on average is 1,000 or 1,500 gallons a month. Why am I paying for that extra 500 or 1,000 gallons that I'm not using every month? So there is a little bit of an affordability and an equity question that comes into this as well. By and large, though, utilities in Alabama are including consumption allowance. 93% of water rate structures in Alabama have a consumption allowance, and 2/3 of the wastewater do. And most of those consumption allowance are around 2,000 gallons a month. So that's a very common practice. We're going to switch gears and talk about volumetric rates. I'm not going to describe each one of these in detail. I think that most of you are familiar with these rate structures. There may be a couple of unique ones in here, and I'll spend a little bit more time on them. But just very, very quickly, uniform rates, or some people call them flat rates, or flat rates and uniform rates seem to be the most common. That's basically where you're charging $2 per 1,000 gallons for any kind of consumption above the consumption allowance. That's usually seen as simple to understand. It's fair. It treats everybody fairly, and it's a very common way of charging especially for wastewater. Seasonal rates, whether it's uniform or other kinds of rates, would be you have one rate structure for certain months of the year, another rate structure or another rate for a different period of the year, where you're charging higher rates for the higher use months. If you're very seasonal demand, you'll be charging much higher rates for your high season than you would be for your low season. And that's to accommodate the additional costs to the system because of those peaking factors. So if you're selling 5 times as much water in the summertime as you are in the wintertime, whether it's because you have a lot more customers or so on, you've built your system to supply that demand, that summertime demand, year-round. So the customers who are using that high volume during those high peak times, they're the ones that are costing the most to run your system and to size your system appropriately. So charging higher rates for higher seasons is an option for utilities to consider, especially for seasonal communities. And it encourages conservation as well. That way you try to drive down those peaking demands and keep keep demand away from the supply capacity of the system. Block rates, they can either be decreasing or increasing. The higher, the more you use, or at some point you're going to have the rate, the dollars per 1,000 gallons change. Whether an increase in block rate structure means that as you use more water, that unit rate, the dollars per 1,000 gallons, increases over time. Like the example we showed earlier in the webinar, decreasing block would be going the other way. The more you use, the lower that volumetric rate is. Decreasing blocks provide price breaks for large users. So it's not really recommended for residential customers because then that incentivizes customers to use a lot of water and not pay significantly more for it. Throughout the country, generally speaking, decreasing blocks have been, well, for lack of a better word, decreasing. They're not becoming, or a lot of utilities have moved away from decreasing block rates for residential customers and into either uniform rates or increasing block rates. Increasing block rates are conservation oriented, and they try to encourage customers to just use what they need and to try to minimize any discretionary use and to really avoid any wastage and any leaks or just forgetting to turn off the hose, for example, outside. So it provides that price incentive to watch the water use and to just be more efficient in your water use. Targeted block rates, which is something I alluded to earlier, is where you have a block rate structure, but it doesn't just increase or it doesn't just decrease. It might increase for some blocks and then decrease later on, or it might decrease to begin with and then increase later. For that, you're really targeting specific types of customers and specific types of consumption. Some utilities use this to have one rate structure for all customers, including industrial and commercial. And what they do is they have an increase in block rate through what they consider to be a residential consumption amount, and then they have a decreasing block that then targets basically the larger users, the commercial and the industrial users. So they try to achieve both the economic development pricing as well as encouraging residential conservation in the same rate structure design. I won't talk about uniform at one block rate. That's a very unique rate structure. And a very common thing, though, for Alabama is to use uniform rates for wastewater that includes a cap. So you have a uniform rate for wastewater, but then any consumption above a certain amount, let's say it's 15,000 gallons, would not be charged a volumetric rate because I think utilities assume that anything above that point is going to be used outdoors and it's not being flushed down the toilet or flushed down into the sewer. So you're not going to be charging for sewer consumption for anything that might be used for water use outdoors. Some utilities might not have a volumetric rate structure. They might just have a fixed fee, a base charge, and stick to that. So that is also an option. It means not reading any meters. It's the simplest and cheapest option, but obviously it provides absolutely no incentive for the customer to watch their water use and to be efficient in their water use. In Alabama overall, most water utilities are using uniform rates. Decreasing block is very popular, but in terms of larger systems seem to be adopting increasing block rates more so than decreasing or uniform. So large systems seem to be favoring increasing block rates. Uniform rates are very, very common, the most common. And then there are some utilities, typically small systems, that are still using decreasing blocks for residential customers. On the wastewater side, it's almost everybody's using uniform rates or uniform with a cap. So looking at the block rate structure designs, here are some of the questions that you have to consider. You need to decide on the correct number of blocks. So do we have, how many blocks do we put? Do we put 15 blocks for the residential customer class, or do you put 2? The more blocks you put, the more complicated your rate structure is, the more prone the data, the meter reading and the billing errors would be because you're dealing with smaller margins between blocks. And also just, it might just be too much. There's no reason to have, I don't think 15, for example, is a good number. But having too few blocks might not also provide the the communication piece, the price incentive piece that you're trying to communicate through the rate structure design, not specifically the rates, but just to say to your customers, hey, we have an increasing block rate. We want all customers to be conserving. Maybe having 3 blocks is visually easier to kind of portray that the strength of that message than having 2 blocks. Deciding on where the block starts and ends is also a key part. I think that to me is more important than the number of blocks, because that is where you then start affecting customers' bills. And if you start a block, very late, then you find that most customers are always paying the first block rate, and essentially you have a uniform rate structure that and only very few pay that second tier block. But if you start the block rate too early, then you might find a lot of customers, their normal indoor use, wintertime demands, like just their day-to-day drinking, showering, cleaning, etc., that exceeds the first block threshold, and you're charging them higher rates for what their basic needs are. And that might be seen as unfair or inequitable. Setting the significant rate differentials between blocks. We have seen rate structures where they've got a block rate structure, and the difference between the first block and the second block, or the second block and the third block, is only 10 cents per 1,000 gallons. That actually is a real example. Not from the state of Alabama, but that is something that happens. And if you just have small rate increases between blocks, then what's the point of having that block to begin with? It doesn't give that message to the customer. So having significant rate differentials between blocks in order to really incentivize consumption within those blocks as you set the block sizes. And then keep in mind the balance between the base charge and consumption allowance. As I said earlier, the higher the base charge, the less you'll be charging on the volumetric side. And if you're including consumption allowance as well, then then the entire pricing signal that you're trying to give through the increasing block rate or decreasing block rate gets washed out, because the base charge then now dominates the entire bill. Meter reading has to be very punctual when you have a block rate. Of course, it has to be punctual for any kind of rate structure, but with block rate, meter reading has to be even more punctual so that you avoid, by mistake, charging customer in the wrong tier for consumption that would have been charged. For example, if you waited too long, you would have charged that consumption in the next month in the first tier, as opposed to them exceeding and getting to the second tier rate. And then replacing the meters frequently and repair lines quickly so that your meter reading is accurate, because now your rates and your revenues are more dependent on the meter reading than it would be under uniform rates. With uniform rates, things kind of even out over time, but with a block rate structure, you want to make sure that you're charging the right volumes in the right blocks as well. So it's a little bit more immediate need to make sure that the meter reading is more accurate, and that you're not, you don't have a lot of leaks as well. If you do have an increase in block rate structure, please be aware of the adverse effects on large families. So a lot of utilities say that affordability is a key issue, and for some communities, not all communities, but some communities, low-income customers might be in larger families or larger households. Larger households mean that they need to use more water just for the basics, the human needs. So if you set a rate structure, an increase in block rate structure, and the first block ends very early, let's say it's 3,000 gallons or 4,000 gallons, then now you have a situation where a lot of customers have large families using more water than that first block, and they're always paying a second tier or a third tier for their basic needs. So we always recommend for people who have, or utilities that have block rate structures, to look and see from census or from other data sources what the household size is, and if you have a lot of large families, who would be paying those second tier rates, and how can you alleviate that pressure on them. And we have some ideas about this, so if this is something that concerns you, please send me an email and I'm happy to talk to you about it. Also on the rates dashboard, if you click on the characteristics tab, to find your utility on the dashboard, click on the characteristics tab, And in there, we already put in what the average household size is for your community. So we've tried to merge that data in from the Census Bureau already for your utilities. The first blocks in Alabama seem to be somewhere between, seem to end somewhere between 4,000 and 6,000 gallons a month, which is somewhere near the average consumption. So that seems to be kind of what utilities are. Remember, the first 2,000 gallons are usually included in the consumption allowance, and then so the first block would be somewhere between 2,000 and 4,000 or 5,000 gallons. That seems to be the most common. Half of the water rate structures in Alabama are block rates, and only 18% of wastewater are. So as far as number of blocks, most utilities have either 2 blocks, 3 blocks, or 4 blocks for water. Only 16% have more than 4 blocks. Again, I won't talk so much about the automatic adjustments. Again, the idea was you can set a rate structure design and set some rate setting rules that say if we end up in a water shortage period, if we have a stage 3 conservation, then automatically our rate structure will change, or automatically our rates will change, and it will raise the price for high usage, so that we encourage customers to conserve, and also to help well, essentially to help incentivize customers to conserve, but also to help recover with cost recovery during the time when people are conserving and the utility needs to deal with reduced demands as well. So that is something that is an option for utilities. I'm happy to talk about it offline. We've talked a little bit about frequency of rate changes earlier. That we recommend we definitely recommend looking at rates every single year. But for looking at rate structures, we also think that you need to look at that every few years as well, 2 to 3 years, and then also review your financial health indicators every year to make sure that your enterprise fund is financially sustainable in the long term. Utilities in Alabama seem to be very active in raising rates or changing rates, maybe not specifically rate structures, but about 2/3 of the rate structures in Alabama had been changed or had raised rates in the last 2.5 years. So within 2-year period or 2.5-year period, 2/3 of the utilities seem to have raised rates at least. It's a very common thing for Alabama. Important note is to avoid maintaining low rates at the expense of the utility's financial health. So, even with affordability being a concern, it serves no one or helps no one if utilities are artificially keeping rates low to help with affordability, because in the long term what happens is that the revenues that you're generating will be low and you won't be able to reinvest in the system. Your system will deteriorate, and that then affects the water quality that you provide customers and then public health in the long term. So it might help in the short term with affordability concerns, but in the long term, it actually creates more problems with public health. And that is the primary goal of utilities to ensure public health. So avoid maintaining artificially low rates. You could have low rates as long as it's helping generate revenues to pay for your system. And then we can help with structuring rates in a way to assist on the affordability side, that not just purely let's lower the rates for the customers. So we're going to go through a couple of examples and maybe 1 or 2 scenarios. I'm going to ask you for your opinion on which scenarios you want to see, but main thing to keep in mind, again, no one rate structure fits all, not even in the following scenario. So even with a scenario, I'll show what a typical response might be. Even within that scenario, there are a lot of variations and a lot of conditions and context that needs to be considered when setting rates. So I'm going to ask for your opinion about which of the following scenarios you would like me to present on right now. A water system, groundwater system with a very small customer base, or a purchased water system, probably a small purchased water system, or you're worried about affordability, or the water demand is too high, or it's decreasing, or your customer base is seasonal. So which of these 5, or you can select all that apply. So it's not just one. Select everything that applies, and I'll go through the first example. If we have some time, I might be able to go through a second example as well. Okay, thank you. So looks like groundwater system with a very small customer base, and followed by water demand is too high or decreasing. So I'll go through the groundwater system scenario first, then I'll talk about water demand is too high. For those who wanted to see about affordability or purchase water system or customer base, the PowerPoint slides have all of the scenarios already written up. So you can read those in the PowerPoint slides from the handouts, or when you get the link later on by email, you can download the slides and read about them. And again, at any point, you can always send me an email. I'm happy to talk about those, especially for your particular utility. Okay, so let's talk about groundwater system first. All right, so for groundwater system with a very small customer base, we're typically dealing with usually a high fixed cost, short term. I mean, for this system, we're assuming not purchase system. This is a all their demand is coming from their well. So entirely groundwater based with a small customer base, so they have a lot of fixed costs and very few customers to spread those costs on. So thinking through, so knowing that as the customer base, thinking through all the different elements of the rate structure design, here are some suggestions. Because you have high fixed costs and a small number of customers, high base charges typically are better for a groundwater system in this condition because you need to generate stable revenues to pay off your short-term fixed costs. And I don't have a slide in here, but for groundwater systems, typically what we see is 90% of the cost or 95% of the costs might be fixed costs for the system, but revenues from the base charges typically are like somewhere between 20 and 25%. So to adjust or to balance that out a little bit more, you would have more or higher fixed costs to generate more higher fixed base charges, so that you generate more from your fixed revenues. And then monthly billing, of course, is better for a small number of customers. But if the cost savings outweigh the cash flow stability for the system, then you might consider bi-monthly. So you reduce the administrative cost of reading meters and so on. Most utilities, or almost every utility in Alabama, is using monthly, which is always a good starting point. So I don't really think that the bi-monthly charging is important. I think the main point here is the base charges and balancing, putting more on the base charges and less on the volumetric is how to help some groundwater systems. Again, each groundwater system will have its own conditions. The other example we want to talk about is, I think it was the water demands are decreasing. Sorry, water demand is high, so it would be the wanting to encourage conservation. For that, monthly billing is definitely important because you want to send the customers a monthly bill, or even more frequent if possible, bill, so that they're always price aware, they're always aware of their consumption, they're always paying something, and if there is a leak or they're using too much water outdoors, they're seeing it in the bill very quickly, and they don't have to wait 3 months later, and they're adjusting because of that. So monthly billing is critical here, or more frequent. Lowering the base charge. So in this case, it's different than the other example. You want to have low base charge and high volumetric rates. So that way, a customer who reduces their demand, reduces their consumption, would actually see a decrease in their bill, a significant decrease in the bill. So that provides a price incentive for them to keep their consumption low. Conversely, if they're going from wintertime to summertime consumption, and they start watering their lawns, and they will see, with low base charge and high volumetric, they will see a very significant increase in their bill in the summertime. And that will provide that incentive for them to just watch how much water they're using outdoors and try to minimize that as much as possible. So that's the way to encourage conservation. Uniform rates or increasing block rates are both very effective for different reasons, but both can be used effectively to encourage conservation. Definitely not decreasing block rates. If you have decreasing block rates and you try to encourage conservation, I would change that. Budget-based rates or other types of rate structures like uniform rates at one block, those things are more unique, requires a lot more programming for your billing software. But once that's done, there are some of these unique rate structures that have even better ways to encourage conservation than increasing blocks in uniform rates. So if you're in that condition where you're trying everything right now to reduce demand because you're near capacity, send me an email and we can talk about some of these more unique rate structures. Seasonal rates, if you have peak demand, a lot of seasonal customers and peak demands, so I would say have higher rates during your high seasons. And then have small block sizes with steep differentials between the rates. So if you have a block rate, increase in block rates, have more block rates and have higher block differences, different rates, higher rates for different blocks. So that way there's a more price incentive for the customer as they use more water. And then consider having that water shortage rate structure or the automatic adjustments that I mentioned earlier on. So I apologize for not having enough time to talk about all these scenarios, and I'm going a little bit over. I'm going to finish this webinar hopefully in a couple of minutes. I wanted to just quickly let you know that we have resources listed here that will help you figure out how to price your rates. So after designing the rate structure based on the conditions that you're facing, you want to figure out how to pay for, how do you charge, how much do you charge for them. There are some resources from AWWA and from EPA. The EPA resource is a free guidebook for small systems. We also have a tool that you can download off of our website called the Rate Analysis Model, where it's a cash flow model. You put in what your expected expenses are, you put in what your expected demands are, and what your current rates are, and it will project what your rates, what your revenues and your expenses will be, and then you can create some scenarios where you adjust the rates to see how you could structure your rates so that you can recover enough revenue to pay for all of your costs. And we can work with you one-on-one on these tools as well. We have a webpage that has a lot of resources about Alabama's rates, so everything I mentioned in today and the webinar from Thursday, the dashboard and the rate survey, all the information is on this webpage. And again, once you have the PowerPoint slides, you can click on the link. Hopefully you've attended our webinar last week on the rates dashboard, so I'm not going to talk too much about that, but that's available right now, and you can click on the direct link to access that. We have a blog that talks about different aspects of rate setting and financial management and benchmarking and demands for water systems, a lot of information that helps with that first step that I mentioned earlier where you're constantly learning about rates and rate setting. Well, signing up for a free blog like that will help you stay in tune with new research and new ways and new best practices. So we recommend people subscribe. It's free, and we only submit one blog post per week. Or you can just go to efcnetwork.org and you'll find a whole list of resources and tools and guidebooks and workshops and webinars and recordings. They're available for small systems, and we can work directly with small systems for free to provide advising and to look at the rates and to look at the rate structure design and to advise on all of these things because of contracts that we have with EPA as well as ADEM and other organizations. So thank you for your attention. If you are interested in signing up for the blog, feel free to just hit yes right here. I will read the question that came in. What is your recommended meter change-out timeline? I get that question a lot, and it's always difficult to answer, partly because it varies on a lot. It depends on a lot of things. It depends on your costs. It depends on how many meters you have, and it depends on what kind of meter change-out program. If you know that you have an AMI meter, if you're planning on switching different types of meter, then I would more carefully consider the capital project first and not worry too much about the timeline. So let the timeline maybe slip until you get to that point where you start phasing things out. But if you don't have a new type of meter that you're trying to install, then have what I've heard is somewhere between 5 and 15 years. 5 years seems a little bit aggressive and a little bit quick, but if you only have a small number of meters, then 5 years, 5 to 10 years might be something that's affordable for the utility. And I've gotten feedback from a lot of people who work with meters Some people say meters are 15 years old can still be, quite as accurate as new meters. Some people say no. Some, prefer that meters are changed out every 10 years. A lot of utilities don't have a specific timeline. They just work with, they change them as they see fit, or they change them when they fail. I don't think that you want to wait that long. I don't think you want to have meters that are 25 years long. So somewhere around 15 years, between 10 and 15 years seems to be kind of where most systems kind of fall under, give or take, depending on the conditions. If there are any more questions, please feel free to submit them, or here is my contact information. Thank you again for your time. I apologize for going a little bit over, but feel free to call me or send me an email, and I'll be happy to schedule some time to talk with you, especially, again, particularly if you're a small water system serving fewer than 10,000 people. We can provide that assistance for free, thanks to EPA grant. We want to thank ADEM for sponsoring our work on the Alabama rate survey and the dashboard, and for providing those resources for water systems in the state of Alabama, and also for funding these two webinars to share this information and to open up a dialogue between us and utilities. So feel free to keep using us, and feel free to reach out to ADEM as well for any low-interest loans that you need for capital projects. And I promise they did not ask me to make a pitch for them, but this is just letting you know that they are available as a resource for water systems. So thank you, everybody, for your time.